Well, good day, ladies and gentlemen, and webinar participants. Today we have an interesting topic, which is retrofitting for IoT. Now, my name is Manfred Schommerz from the technical support here in Trier, in our studio where we'll hold the session of today. And with me, I have two of our specialists standing next to me. I'll introduce them now, who'll do the actual presentation of retrofitting and IoT. The first person is Adi, and to assist him as well, Ravindra, both of our top specialists in this field. As far as the webinar is concerned, we'll hold it for about 30 minutes. You'll be muted, but in the meantime, you can certainly ask your questions via the chat function. And without further ado, I think I'd like to switch over to Adi and Ravindra. Welcome, Adi and Ravindra.
Thank you, Manfred, for the sweet introduction. The topic today for our webinar, retrofitting for industrial IoT. We are trying to show you how we can digitize analog systems, specifically in the industrial environment. For the agenda today, we'll start with a general introduction to retrofitting and how we can make new from old, right? So this is the concept of making sure that the old devices are capable of connecting to the internet so that we can use them for a longer period of time.
Yes. We will also see some of the benefits for retrofitting and wireless technologies which can be used for the retrofitting purposes. And later we will see some examples, use cases, and live demo as well. And at the final stage, we will open the floor for question and answers.
Correct. When you talk about retrofitting, what do we think of in general in a generic example in our daily life? Let's see if we can get an example from the televisions, for example.
Yeah, for sure. The old televisions which are not capable of for the IP connectivity purposes, those can be converted into the smart IP connectivity TVs. So we will see some of the examples for predictive maintenance, as well as some of the examples for which can be used inside the factories. So we'll see in the presentation.
Correct. So when talking about these televisions, again, you have an old television at home that is no longer, we don't want to see the standard analog TV anymore. We want to stream content from the internet. The idea here is that you can use a Apple TV stick or Amazon Fire Stick or whatever that is available, plug it into your HDMI port that is available on your television, and then suddenly you have a smart TV. That's the idea of, in general, about retrofitting. Now, the question is, how do we do this for industrial devices, right? So you have an industrial device or an equipment that is a machine that is running for a long time now. Mm-hmm. The new devices, new equipment or new machines already have some kind of internet connectivity. But what do we do when these devices don't have such things? That is exactly where IoT comes into rescue.
Okay.
So you have the possibility to mount a lot of different sensors to actually sense the physical environment in which these machines are working, right? And then the idea is to use to send these machine data over a wireless connectivity link onto a data platform where you can collect a lot of data, and you have a lot of advantages when you have this data available on hand.
Yeah.
The first and the most important thing that you could do is, when you have all this data available, you start seeing patterns in data with which you can start automating as well as optimizing the processes of the machine, right? And with this optimization and automation, you can actually bring in predictive maintenance to make sure that your equipment is present and there is no downtime in the production in general. This in turn will increase the safety and security of people around who are working with the machines, and make sure that the quality of the product that comes out of the machine is kept really high.
Yeah.
Right? We'll give a lot of different real-time examples as and when we talk about these things in the upcoming few minutes. But the most important benefit having IoT to retrofit it onto an old machine is that you can do remote monitoring and control, which kind of provides a lot of different benefits that we spoke about earlier.
Yeah. So let's see what are all benefits and why we need the retrofitting. So retrofitting in terms of numbers. So as per the WDMA report, the average life cycle of any factory equipment is close to 20 years. And as per Accenture report, 85% of all the industrial plants in Germany are not yet connected digitally, or they cannot be controlled over the from the cloud, I would say.
Correct.
So what the benefits this retrofitting brings, that the useful life of the system increases from 10 to 15 years when you make these devices or the machines smart, I would say. And reduce training efforts compared to the new systems, and it reduce the fear of digitalization.
Correct. So you have the chance that the employees are still using the old machine.
Exactly.
But with new features.
New features, yeah.
Okay.
And it's good for the environment as well, and the investment generally pays off within the 2 years. So as per the report from Bosch, let's say example, if you invest 25,000, your annual savings will be close to 200,000 euros.
Okay. So in the end, we are also talking about sustainability, because we are not throwing away old machines, but increasing the lifetime by 5 to 10 years. So overall, they reduce global wastage and so on. Yeah, which means that retrofitting is a win-win for everybody.
Exactly. Yeah.
Let's see. Moving on.
So, why do you think, Adi, that Wi-Fi is a good option for the retrofitting?
Yes, I mean, talking about the wireless connectivity parts. So we are talking about somehow bringing sensor data onto the cloud. The first and the foremost thing that comes to my mind is that a lot of industrial halls already have Wi-Fi network available. So in terms of retrofitting, it is very easy to have to reuse the existing Wi-Fi networks and connect the new sensors onto these networks. So that is one of the most important things. The second thing that comes to my mind is about cloud connectivity. Wi-Fi connectivity usually provides the IP-based connectivity over the internet onto the cloud platform. So it is very easy to achieve or send data directly to the cloud. Further, although typically Wi-Fi is not low power operation, but you can still use modules that offer a nice sleep mode. So most of the time, the Wi-Fi module is switched off or in deep sleep mode and still save a lot of power. So you can still have battery operated sensors that can connect over Wi-Fi. And finally, if you use the state-of-the-art security features, you can make the whole communication also secure. So these are some of the benefits of using Wi-Fi for retrofitting.
Yeah. So that means your data is secure from your device until the cloud, end-to-end secure.
Correct. Now, if we move on and see what we offer in terms of secure Wi-Fi connectivity, we have a plug-and-play IoT connectivity module, Cordelia.
Yeah.
That is quite recent on the market. It provides plug-and-play connectivity to multiple cloud platforms that are available. The idea here is to act as a UART to cloud bridge, which is really ideal for retrofitting applications. So you can use your old RS-232, RS-485 kind of communication links and connect it directly to this module, which in turn will forward the data that comes in through the serial interface via the Wi-Fi onto the cloud platform directly. This module is based on or designed for cybersecurity, which means keeping cybersecurity in mind, which means that it will provide a real good basis for a secure end application for any embedded system. Mm-hmm. Moving on, Ravindra, can you tell us a little bit about how cellular connectivity could be suitable for retrofitting applications?
So when it comes to the wireless connectivity, I generally divide in two different parts. One is that a small to medium range of connectivity solutions like Wi-Fi, Bluetooth, or any other connectivity solutions. While when it comes to the cellular connectivity, it's for long range. Mm-hmm. And good part about this technology is that it provides the global coverage. So it's not dependent on to the small or the medium range, but it's the kind of global coverage. So, and it offers kind of a cloud connectivity also because it has already integrated lots of protocols which are generally used for IP connectivity type of protocols like MQTT or LWM2M. And the LTM and NB-IoT especially were designed for the power waste kind of applications where they consume very low power, and of course your data is secure because they are using same encryption algorithms which being used in other cellular technologies like we are using in our cell phones or mobile phones. So your data is secure when it goes over the air.
Okay. Which means that, I mean, with respect to global data coverage, we have an option to put it in an industrial environment where there is no Wi-Fi, but still get connectivity.
Exactly. So global coverage plus long range coverage enable the devices directly send data from your field to the cloud platform. And so for an example here, what we have given is that your machine is equipped with the sensors or different type of sensors and the cellular wireless connectivity. So eventually this wireless connectivity solution like LT, CAT-M or NB-IoT module will send the data to the base station, nearby base station where they have the coverage, and that will send to through core network, and eventually the data you can see or visualize, make a decision on the cloud platforms.
Correct. Can you tell us a little bit about our offering with respect to cellular technology?
Yeah, so we offer one module called Adastria, and this module has the support for LT, CAT-M and NB-IoT. So it gives you the advantage or the flexibility where, let's say, you are deploying your devices in the countries where you do not have the coverage for LT, CAT-M, then you can choose the NB-IoT.
Okay.
And as a vice versa, where the NB-IoT coverage is not there, you can choose the LT, CAT-M. So one module can be used for both the technologies. And it has the integrated GNSS, which supports GPS and GLONASS satellite systems. It has integrated user MCU, ARM Cortex-M4 with 1 MB of flash and 256 KB of RAM. So this integrated user MCU is dedicated for the our customers' applications. And all these parts are integrated very in small form factor, 13x4 to 14x6. And if you'll see, all sort of IP protocols are supported already out of the box: IPv4, 6, TCP, UDP, MQTT, LWM2M, and HTTP. And in terms of interfaces, it has more or less every interface which are generally used in the industries: USIM, UART, I2C, and ADC and JTAG for the debugging purposes. So, and it has the secure MQTT and LWM2M for the cloud connectivity also.
Okay. Now, shall we take a look at a couple of real-world examples where we have used our connectivity modules and sensors, and most importantly, FeatherWings, right?
Yeah.
When we have used the FeatherWings to create a couple of really good examples where there were a lot of benefits achieved retrofitting old devices, correct?
Yeah.
So the FeatherWings, talking a little bit about FeatherWings, these are set of development boards that we have, that we offer for every radio technology more or less, and also for the sensors. These are plug and play connectable devices that you can use for prototyping. You don't need any additional hardware development, which means these are perfect tools for rapid prototyping.
Yeah.
Let's take a look at the first example.
So this is kind of one old 15-year-old CNC machine from some hardware technology manufacturers, and it has proprietary control softwares, and it does not have any IoT compatibility, so it's IoT incompatible control interfaces with proprietary software protocols. So when we use this kind of machines, when machines are not digitally connected, then what issues you will have? You will have kind of unplanned downtimes. Mm-hmm. You will have stagnant material supply, increasing the rejections, and expensive service and maintenance of these kind of devices or the machines. So, and manual recording of faults and downside times is not possible. And if you'll see in terms of tampering, if you would do any tampering with the internal parts of the machine, then it will void your service contract with the manufacturer.
Correct. So with all these things, what we need is a non-invasive method to monitor and control the machine so that you can preempt and plan the downtimes. So this is a kind of predictive maintenance that we require to make sure that the device keeps running without actually having any impact on the productivity of the production that we are talking about. Correct?
Yeah.
This was the real world example that we are talking about. So what happens when we do the retrofitting, right?
Yeah. So same machine which we were talking about in the last slide, now we are using the retrofitting to make it a smart machine or the digitally connected machines. So machine is retrofitted with the wireless connectivity so that it can send the data directly to the cloud, and the sensors, which are some different type of sensors like vibration, acoustic, optimistic, and optical and current sensors, which will collect the data or the health of the parts of the machine, and they will use the wireless connectivity like Wi-Fi or LT, Cat-M, and NB-IoT to send this data over the cloud. And then on the cloud, you can use the data visualization, just as you will see the data that, okay, now this machine parameters are downgrading and now it needs some sort of maintenance. So you can predict the maintenance and we can do well-planned maintenance. And potentially you can use AI/ML to enable the predictive maintenance and, process optimally. So retrofitting is a kind of non-invasive method to reap the benefits of the IoT for the old machines.
Yes, which means that we are not actually getting into the internals of the machine in any way. We are just fitting sensors and connectivity on top of the present system to make it more smart.
Exactly.
Right? That's exactly what we did with the help of our partners to create a kind of a pilot project wherein we retrofitted this specific industrial cutting machine. It's a CNC machine. The motor head that you see here, let's zoom in a little bit, was fitted with our acceleration sensor. So this enables us to measure vibrations over a period of time. There was, as you can see, it's within the motor head, so that it was. You can see it has been placed there with zip ties and so on. So it was really a pilot project to actually do a feasibility study on monitoring such machines. We powered it when we couldn't get into the mains of the machine, so we powered it using a solar panel, and we had a battery that was storing all the energy. And this is how this whole, this clearly shows you can. This is a typical low power application, battery operated, and using our proprietary radio module in this case, we were able to transmit the vibrations or the sensor data from the acceleration sensors onto a gateway. Additionally, we were also monitoring the current optimization using current sensors. And finally, we used the cellular module that you can see here in the picture to transmit data onto the cloud.
Okay.
What we were able to achieve with the combination of the two sensors, of course, we had our partners that was taking care of the AI and the optimization, data optimization and data processing part. So with the help of the partners, we were able to detect or clearly identify processes. For example, in this case, you can see in the graph process A and process B. You can see the current consumption when the process A happens, and current consumption and also the confusion matrix, where you can detect with high probability these processes. And the idea here is that if we detect that a certain sequence of these processes, for example, process B occurs before process A happens, then there is a high likelihood that the machine is going to be damaged very soon. So there needs to be a part that needs to be replaced. So if this sequence of processes happen, then the person monitoring the machine can already order the parts that are necessary for this particular situation, and then correct the faults during a weekend, for example, or during the downtime of the machine.
Yep.
So with this, we were able to show the proof of concept that using very simple sensors, without actually getting into the machine in any other way, we were able to detect faults and perform predictive maintenance on the end device. Let's see if we can show a couple of other examples. So here you can see again our FeatherWings coming into rescue. So here is an old welding machine that was being used in the production. Again, here it had a typical RS-232 interface that you can recognize from the old printers here. So we have a serial bridge feather wing which converts this RS-232 communication interface into a UART interface. Further, this was here we were using the Wi-Fi connectivity. You can see our Calypso Wi-Fi module on top. So the idea was to monitor the welding parameters, the cycle times and the machine load, as well as utilization from the data that was put out on this RS-232 interface, right? So we don't need any sensors because the machine itself gives out these kind of data on the RS-232 interface. All we did was collect the data of these. There are certain parameters like the temperature that was used for welding, and there were parameters like how long the resistance of the thermode that was being monitored, and so on. So with the data that we collected, we were able to recognize that the most often occurring problem was that the thermode gets destroyed because of frequent use. So what we were able to optimize in this case is to reduce the power with which the welding was performed in order to conserve this thermode and make sure that we use these thermodes longer. And in case that we need the replacement of the thermode, we were able to predict it well in advance to make sure there was no downtime of the machine in the end. Similar situation, we have a winding machine. In this case, it was not really important to do any kind of predictive maintenance or anything because this was a quite reliable machine. But the problem was we didn't have a smart interface. So this was old. It was not connected to the internet. So again, via RS-232 interface, we were able to connect it via Wi-Fi onto our cloud platform where we were collecting a lot of data over a period of time. This helped us to improve planning in this particular production and improve the efficiency of the whole production process in the end, making sure that we can produce more and of good quality products in the end. So these are certain examples that we have from the real world, but we can also talk about what we are going to show you today, right? We are having a live demo that we have planned for today. So in this case, of course, we cannot bring these big machines into this room and into the studio. That would be really difficult. So let us see if we can use this power supply that we have that has a RS-232 interface, and we use the same setup that we have in the previous slides. That is an RS-232 to UART bridge. That is our serial bridge feather wing, and then send data via Cordelia Wi-Fi module securely to the cloud. And we are able to also control the entire power supply using a dashboard that we have created.
So Adi, when you talk about the Cordelia, it means that does it has some dependency on the cloud? Let's say our customer want to use the AWS or Azure, or it's independent of the cloud platform.
So this is a very flexible module. So with which you can actually configure the module itself to connect to several different cloud platforms. It doesn't matter which one it is. We provide a secure MQTT connectivity. So as long as the cloud platform supports MQTT, which all the most popular cloud platforms do. So it is very simple to configure Cordelia module to connect to any of these cloud platforms. Additionally, we have our partners, CryptoQuantique, that offer a provisioning software as a service platform called QuarkLink. With this, you can remotely configure the Cordelia module to connect to several different cloud platforms.
Wow, that's the out-of-the-box kind of zero-touch provisioning, you would say.
Correct. That is the zero-touch provision that we are talking about. I think without a further ado, let's go to the live demo, right?
Yeah.
With which I would say, let me get the power supply that we want to retrofit.
Yeah.
Okay, here we go. That's the power supply. Let me switch on the power supply first and see if we can get it running. So this power supply will be powering our LED strip today, just to show you how it works. Right, so let me connect it to channel 1, for example. Okay, now this is done. Now let me pick up the stack that we have here. So this is the RS232 serial bridge FeatherWing, which converts the RS232 to UART. We have ARM Cortex M0 microcontroller on the FeatherWing M0 Express that we are using. This microcontroller in turn controls the Cordelia Wi-Fi module. So this is the module that connects provides connectivity to the cloud. So let me connect this particular FeatherWing stack onto the back of the power supply, basically via RS232. And with this, now we should be able to completely control the power supply using a smart device. Let me get my iPad quickly. Power it on and see if we can access the dashboard. So in this case, you can clearly see there is the dashboard here. And I should be able to communicate with the device. Let's see if I can read the device ID. You can already see there is the ID that has come up here. We can select channels. You can see that the channel 2 is now selected. And more importantly, let's see if we can activate channel 1, switch it on. Seems to have turned on already. In a couple of seconds, the LED lights should start glowing.
Yeah.
So basically, you are creating a smart interface to the old power supply here. You don't have to use the buttons anymore. And the most important point is that you can use this dashboard from anywhere in the world. Imagine this situation if you can have an overview and control of industrial machine from anywhere in the world. So that is what we're talking about. Let's switch off the power supply, for example. Yeah, you can basically play around. You can do everything that you can do on the front panel on an iPad now. So this is the power of retrofitting and using IoT to perform retrofitting on old devices.
So it means that your old device, which does not have any IP connectivity, has been now converted into the IP-enabled, I would say that device or the smart device, so that it can be controlled, it can send the data to the cloud, and it's very important part, because as we have seen, there are almost 80% of the equipment in the factories which are not connected, so our customers can make use of this retrofitting to enable these devices to send the data and do the predictive maintenance.
Correct, and the benefit again being I don't have to now get into the electronics of this power supply. I could just use the existing interfaces.
Yeah.
So no invasive connections. I don't have to tap into any additional sensors. It's just the RS232 that is already present here. Additionally, you can also use, provide connectivity to any cloud of your choice. So there are a lot of benefits, right? So you don't have to really invest a lot of capital upfront or time upfront using the rapid prototyping stuff that we have with FeatherWings. You can actually create such prototypes right out of the box very quickly. With this, I think we are coming to the end of our session. Let's take a look. Manfred, if you have some questions to ask from the...
Yes, gentlemen. Adi and Ravindra, thank you very much for a very interesting session showing us how to actually retrofit a machine, getting data from my sensor into the cloud and talking back to the machine. So the whole concept of IoT and retrofitting. Bodo and myself have been monitoring the background here and doing some control. And in fact, there was one question here, maybe to you, Adi. There are some upcoming regulations in the EU with respect to cybersecurity. Any idea how this will impact IoT devices?
Sure. I mean, this is a very, very interesting questions. There are a lot of cybersecurity regulations that are upcoming worldwide, but in the EU, we have the Radio Equipment Directive, which is applicable for any device that has any wireless connectivity, which is either receiving or transmitting wirelessly. So there is, since 2022, there has been additional delegated act on cybersecurity that has been added to the existing Radio Equipment Directive, which means along with EMC, health and safety, we have now cybersecurity norms that we need to take care of when bringing any device into the market, right? So with this new radio equipment directive regulations, we have a new norm called EN 18031 2024 that is being released by end of this year. It has not yet been harmonized, but this focuses specifically on IoT devices, embedded devices that have radio connectivity. But the good thing for our customers is that we are already on it. We have made sure that the Cordelia Wi-Fi module, of course, is certified according to the 18031 standard, which means we provide a really good basis for our end customers to get their end product certified. Again, irrespective of which module we are talking about, it's Bluetooth, Wi-Fi, cellular, we make sure that we provide all the necessary security features, and we enable it most of the times by default, so that our customers doesn't have to really bother too much about it. That's the idea.
Yeah, well, lovely. Adi, thank you very much for this interesting bit of information on cybersecurity, which is becoming more and more important.
Additionally, I would like to add that we are coming up with a lot of seminars, webinars specifically with respect to cybersecurity topics. So I would say keep in contact, have a look at our newsletters, our websites, and so on, so that you also can register to one of these sessions to get a deeper insight into this topic.
Right, the man for cybersecurity. In fact, I have one more question here, and I think this should go to Ravindra. What should we keep in mind with respect to certification when using our cellular module?
Yeah, thank you, Manfred. I think it's very important question. And in terms of cellular, when we talk about cellular, the certification part is really complex and which our customers generally does not understand well. So when we talk about the cellular, we need all three different type of certifications. One is the regulatory certification like CE or the FCC. These type of certifications are common for all the radio kind of technologies. And the second type of certification, which is very specific to the cellular only, is the industry specific certifications. There we have two different types of certification like GCF or the PTCRB. GCF is mainly kind of in Europe, or the PTCRB is mainly for US. And then third part of the certification comes is that is the operator specific certification, like you have Deutsche Telekom or Vodafone or any of those network operators. So when we talk about our own Adrestria module, our module is already GCF certified. So that means that if customer integrates our module in their end application, they just need to do the delta testing for GCF, and then they can directly contact the operator to connect on their network. So, and we already have the good partnership with the Deutsche Telekom. If our customers buy the module from us and the connectivity from Deutsche Telekom, they can even avoid those certification process. So they can integrate our solution in their applications.
Okay, well, thank you very much. Here we have our two specialists. Maybe one last little question which I see here. Where can we order evaluation boards or equipment? Could you tell us more?
Sure. I mean, for the modules that we spoke about, each of them have come with an evaluation kit. So you have in the evaluation kit everything you need to take this radio module into operation. Additionally, we offer FeatherWings for every technology that we have. The FeatherWings that you see here, so they are really very good. It's not just evaluating a specific part, but it's useful in evaluating the entire system, entire concept that you want to implement. All these things are available on our website, of course. You can always write an email to our colleagues at support. That would be you, Manfred, at wcs@we-online.com, right?
Yes,
Or you can contact your nearest sales colleague from us to come by and show you our portfolio of radio modules and sensors.
Okay, well, thanks a lot. Ladies and gentlemen, webinar participants, we have already exceeded our half-an-hour session here, and any outstanding questions we'll answer afterwards by email, and we'll get back to you. But in the meantime, then, I would like to thank Adi and Ravindra for their participation, and also in the background, Bodo for handling the webinar. With that, and without further ado, I wish you a good day, stay healthy, and till next time, keep well.
Thank you.
Thank you. Bye.
Bye.
Bye.